How you doing? This is the lesson for 11.1, and the lesson talks about circumference and arc length. Now, circumference is actually a prior knowledge. The equation for that is the following. Circumference is equal to 2 multiplied by pi multiplied by the radius of the circle. Now, the radius of the circle is the distance from the center of the circle to the circle. Now, the diameter is the equivalent to 2 radiuses. Now, in the previous chapter for chapter 10, even though we didn't cover much of it, we did talk about arc measure, and arc measure is pretty much just, or arc length is just the measure of a portion of the circle. So that's one of the things that we're going to be looking at in this section. So this is in the exploration, page 314. Okay, so in the first part, they're asking me to find the length of each gray circular area. Now, it's really difficult to see the gray part, so I'm going to use a highlighter to highlight what it is that they want me to find. So in part A, they want me to find the length of the entire circle. So pretty much the circumference. Now, the circumference, as we mentioned, is equal to 2 multiplied by pi multiplied by the radius. Now, for this lesson, we're going to be using the pi e in the calculator rather than 3.14, just for accuracy. Now, in this graph, you can see that the distance from the center of the circle to the radius is 4. That means that this radius is going to be 4. So we're going to provide our answer in terms of pi and in terms of a decimal. So this is going to be 2 times pi times the radius, which happens to be 4. Now I'm going to use a different highlighter to show you guys why the radius is 4. The distance from there to there. So that radius is 4. Now if we simplify this, we multiply the 2 and the 4 to give me 8 pi. Now this is the exact area, but they also want me to give the approximation. So what I do is I put it in my calculator, 8 multiplied by pi, and the pi key in this calculator is, can't find it, hold on one sec. Okay, I found the pi key. All right, so my calculator has it right there. It's a second function and it's kind of small. But you can use 3.14 as well. So second pi, and I get 25.1 to the nearest 10th. And that would be the distance around the entire circle. Now, the process for finding this one is pretty much the same thing, but in this problem, they want me to find only 1/4 of the circle. So basically this much of the circle. Now that only represents 1/4 of the circle. So using the same equation, 2 pi times the radius, but in this case, this equation represents the entire circle, but I only want 1/4 of that. So I'm going to multiply that by 1/4. Other than that, everything else is still the same. So the radius is still 4. I'm going to steal the answer from this one. Okay, I'm going to slide over here because this portion right here happens to be 8 pi. So the only thing that's left is multiply it by 1/4. And this reduces the 8 and the 4 divide out to give me a 2. So I get 2 pi. So 2 pi would be the distance around this 1/4 of the circle. So if I go into my calculator and multiply it by 2 times pi, I get approximately 6.3 if I'm rounding everything to the nearest 10th. Okay, so it's 2 multiplied by pi. Now, if you're using a TI-10, there is a pi key. If you're using a standard calculator, just type in 3.14. So the circumference is 6.3. only of that part right there. Okay, so we call that the arc length because the entire length would be the circumference of the circle. Let's move on to the next example, example C. Now, here they want me to find the circumference of 1/3 of the circle. Same process. The radius is a little different in this case, so we'll come back to that in just a second. Circumference equals 2 pi r, but I only want 1/3 of the circle. So what I'm going to do is I'm going to multiply it by 1/3. Now the radius in this case is 1, 2, 3, 4, 5. The radius is 5. So I'm going to substitute that in place of r. I'm going to leave my answer in terms of pi at the end, and then I'm going to put it in the calculator. 2 times 5 times 1, that's 10 over 3. My exact answer would be 10 pi over 3. If they want the exact answer, that would be your answer. If they want a decimal approximation, then you would have to put it in the calculator. Okay, so to put it in the calculator, you do 10 times second pi, or times 3.14. The answer is not going to be that way off. And then divided by 3, and that gives me about 10.5. Now, in the last part here, they want us to do 5/8. So the process is exactly the same, but instead 5/8. So the radius of this circle happens to be 3. 2 pi times 3 times 5 over 8. Multiply all the numerators. 2 times 3 times 5, that's 30. But this is not fully simplified because they're both divisible by 2. So divide 30 and 8 by 2, and you're going to get 15 pi over 4. Now, if I want a decimal approximation, all I have to do now is put it in the calculator. 15 times pi, then divided by 4, and I get approximately 11.8. I'm rounding everything to the nearest tenth. But I want to show you something now that we have all 4 of the answers. Let's go back to part B. Now, here in this part, they wanted only 1/4 of the circle. My question is, guess what angle this is right there? Well, 1/4 of the circle, if you think about it, the whole circle right here is 360 degrees. Half of it is 180, and 1/4 of that is 90 degrees. So 1/4 is the equivalent to 90 over 360. So when I multiplied this by 1/4, I pretty much multiplied it by 90 over 360. It's just the unreduced form. Now, here, this represents 1/3 of the circle. So if I look at 360 and divide it by 3, that is equal to 120 degrees. So 120 degrees over 360 represents 1/3. I wonder how much this is going to be. Well, it's very easy to find out. 360 divided by 8. So every eighth is 45 degrees. And I have 5 of those, so I multiply that by 5, and I get 225. So 225 over 360 is equal to 5/8. So what does this allow me to do? This allows me to find the arc length of any circle given the radius only and the degree of the arc measure, which is what we're going to be practicing in a couple of minutes. Now, let's turn over to the next page. and this is on page 315. Now, here's a bit of an application to circumference. It says, the rider is attempting to stop with the front tire of the motorcycle in the painted rectangular box for a skills test. The front tire makes exactly 1/2, keyword 1/2, additional revolutions, meaning full turns, before stopping. The diameter of the tire is 25 inches. Is the front of the tire still in contact with the painted box? So in other words, this tire right here that I'm going to draw right there, it says it has a diameter of 25 inches, which means that the radius is half of that. Now, I like working with the radius rather than the diameter. So I'm going to divide 25 by 2, and that's going to give me 12.5. So since this is going to make only a half a turn, the degree that makes this wheel turn halfways is 180 degrees, because from here to here is 180 degrees. So the arc length, or half of the actually no, let's just say we're looking for the circumference of this. Okay, the circumference of this is going to be, or half of the circumference, you would say, half of the circumference is going to equal 12.5, actually 2 pi r, my bad, 2 pi times the radius. The radius is 12.5. So this right here gives me the whole circumference. So in order to get half of that, I have to multiply it by 1/2. Okay, so I'm really looking forward to only this piece right there. Okay, so I think I'm confusing you guys. I think we're pretty much going to talk here about the arc length. Okay. All right. So arc length, E, ugly handwriting. You know me. Okay. So this is the whole circumference. This is half of that. So this gets to divide out, and I get to have 12.5 pi. So 12.5 times pi, I'm putting all this in the calculator, gives me approximately 39.3 inches. Now, what I want to do is I want to convert that into feet. So this 39.3 inches, I'm going to divide it by 12 inches to get it into feet. So divided by 12, and I get about 3.3 feet. Now, the painted portion is only 3 feet long, which means that the length of the tire, or halfways, is more than this. So that means that the tire went past the paint box. All right, so let me tell you guys where the problems are going to go. Okay, and this is in the chapter 11 journal. Make sure you guys download it or take notes on a piece of paper. So let's move on to page 316. On page 316, you're going to be putting problem number 1 right there. You're going to be putting problem number 2 right here. And once again, we've already talked about the circumference of a circle to be 2 times pi times the radius. I usually tend to avoid this one. It causes a lot of confusion. So we're going to stick to only 2 pi r. Now on the next page, I'm going to modify the equations that they're giving you right here, because I don't really quite like the way that they introduced them. They have this equation or this equation. Personally, I don't like this one. It just creates more confusion when you have to set it in terms of proportion. Okay, so the way that this equation is going to work is the arc length of AB, which happens to be the minor arc here, is going to be 2 pi r. Now, I was putting the fraction on the right-hand side. You can put it on the left-hand side as well. It's pretty much the same thing. So this right here is represented by that angle that is right here. So this angle right here, if it's 30, 30 is here. 40, 40 is here. 50, 50 is here, and so on. So all you really need to know to find the arc length of this is the radius and the angle right here. And that's the equation that we're going to be using. So if I were you, I would scratch off this one because it's going to confuse a lot of people. Now, there's a concept that we are going to skip. I don't think you need to know these right now. You probably will need to know these by the time you get to trigonometry or calculus, but for the time's sake, we're not going to worry about that. We're not going to worry about degrees to radians either. Okay, so we're going to put problem number 4 right there. And this is on page 317. All right, so let's go ahead and get started with the examples. Okay, here's number 1. And I apologize if my paper is a little wrinkly, but my children got to the paper before I did. So it's a little wrinkly, but it's still good. All right, so for problem number 1, it says, find each indicated measure. A, the circumference of a circle with radius of 9 centimeters. Okay, so let's start with A. They want me to find out the circumference of a circle. Okay, this is what they want, with a radius of 9. So let's remember what the equation for the circumference of a circle is. The circumference is equal to 2 times pi times the radius. So the radius in this problem happens to be 9. So we're going to get two answers. We're going to get the exact answer and then the decimal approximation. So 2 multiplied by pi multiplied by the radius, which happens to be 9. This simplifies to 18 pi. Now that's the exact answer. The approximation to that is whatever 18 times pi is going to be. And I get about 56.54, so I'm going to round that. Now, how is it different if you just use 3.14? So 18 times 3.14, you can see it doesn't really make much of a difference. Because when you're rounding to the nearest tenth, you still get about the same. So if you want to use pi or if you want to use 3.14, go ahead. Now, if you use 3.14 and your answer is incorrect, go back and use pi, and that might be what will be wrong with your solution. It's just in the rounding, guys. Okay, part B. So the circumference, by the way, is 56.5 centimeters. Now for B, we have a radius of a circle with circumference of 26 meters. So in this case, I have the circumference, I do not know the radius. So I need to work my way backwards. I still use the same equation, 2 equals 2 pi r. I'm going to substitute the circumference with 26. And I'm going to, well, I can't substitute anything for the radius because that is my unknown. Now I want to solve for the radius. Now what I want to do is I want to get r by itself. So what I'm going to do is I'm going to have to get rid of the 2 and the pi. So to do that, I'm going to divide this by 2 pi, both sides. Those divide out, and now I get my radius to be 26 over 2 pi. Now I could reduce that, 26 and 2, they're both divisible by 2, and I get 13 over pi. If they want the exact answer, that's what you might want to put. If they want the actual decimal approximation, I'm going to divide 13 divided by pi, and I get approximately 4.1 to the nearest tenth. So this will be 4.1 meters. And that, ladies and gentlemen, is example number 1. Let's look at example number 2. Okay, example number 2 has three parts to it. Let's look at A first. They want me to find the arc length of AB, that's this one right here, with a radius of 8 and a central angle of 60 degrees. So if you remember, the equation goes like this. Arc length of AB is equal to the angle, okay, I'm going to call that angle X for now, okay, X over 360 multiplied by 2 pi r. That's the main equation that you're going to use. You are looking for the arc length of AB. Okay, so the arc length of AB is equal to, now this x, what is this x? This x represents that central angle, which is 60. 60 over 360 times 2 times pi times the radius. The radius happens to be 8. Now, you want to simplify this out before you put it in the calculator. There's a lot of stuff you can simplify out here. So for example, the 60 and the 360, the zeros divide out. 6 and 36 are both divisible by 6, so that gives me 1 over 6 times 2 pi times 8. The 2 and the 6 are divisible by 2. That gives me 3. So that is going to give me 8 pi over 3. So that would be my exact answer. If I want a decimal approximation, I simply multiply 8 times pi, enter, divided by 3, and I get approximately 8.4. Now, for B, they're actually asking me for the circumference. Okay, so we're going to kind of manipulate this equation a little bit, because if you have the arc length, and that's equal to x over 360, and that's multiplied by 2 pi r, think about it like this. 2 pi r is your circumference. So if you solve the equation for 2 pi r, then you have the circumference. So let's just plug things in. So the arc length right here happens to be 4.19. 4.19 equal to, the central angle is 40 over 360 times 2 pi r. Now remember, I'm not solving for r. I don't need to. So 2 pi r is my circumference. So all I got to do is I got to get rid of this. Now, I could simplify it. 40 and 30 is 360. They're both divisible by 10. 4 and 36, that reduces to 1/9. So 4.19 over 1/9 times 2 pi r. Now, to get rid of that 1 over 9, I have to multiply both sides by 9. So I multiply this by 9 and this by 9. And that gets rid of that. So 9 times 4.19, that's equal to 16.8. And that's equal to 2 pi r. Now remember, 2 pi r is the circumference. So the circumference is about 16.8. Now, for the last one, let me zoom out a little bit. Okay, so for the last one, they want me to find the measure of RS. So the measure of RS, I'm assuming they're talking about the major angle. Actually, they're talking about the minor angle, not the major angle. How do I know? Because this is a measurement right here. Okay, so we are about to find out what is this angle right there. So we're going to use the same equation. The arc length of, in this case, RS is equal to x over 360 times 2 pi r. Now the radius is given to me as 15.28. Okay, so we know this one. Now we also know this one. What I'm looking for is now x. So the arc length happens to be 44. And the radius is 15.28. So there is a lot of simplifying to do before we even do anything. I need to multiply this and divide it by this, and then times pi. And then whatever answer I get, I have to get x by itself. So let's just go ahead and try to figure out what this is. 2 times 15.28 . Now that's this times this. That is 30.56 times pi. Now, my goal is to solve for x. So what I'm going to do is I'm going to get rid of 360. I'm going to multiply the 44 times 360. So I'm practically multiplying 360 on both sides. And that gives me, it's a big number, 15,840. And that's equal to 30.56 pi times x. So now what I'm going to do, and yes, the numbers are a little bit ugly. That's okay. Divide both sides by 30.56 pi. Now, I'm going to put all of that into the calculator. Okay, so I'm going to divide that by 30.56. Oops, got to clear my calculator again. 15,840 divided by 30.56 times pi. And I get about 164.98 to the nearest tenth. It's about 165. So yeah, this part is probably a little bit more complicated, but simply follow the steps and make sure you make the correct substitutions. Otherwise, things are not going to come out correctly. All right, let's take a look at number 3. Okay, the dimensions of the car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So we need to find out how much it makes in one revolution. Pretty much we need to find the circumference. So to find the circumference, we need to find out, well, what exactly is the radius? Now, to find the radius, all we have to do is add up all of these, find the diameter, and divide it by 2. So to find the radius, all I have to do is add 5.5 plus 15 plus 5.5. So that's going to give me 5.5 plus 5.5, that's 11, plus 15, that gives me 26. So in order to get the radius, I have to divide that by 2. So 26 divided by 2 gives me 13. So my radius is 13. Or what you can do is find half of this, which is 7.5. Add 7.5 with 5.5, and you get 13 as your radius. Now the circumference of this whole tire is going to be 2 pi times the radius. So that's going to be 2 pi times the radius of 13. So that simplifies to 26 pi. Now, that would be the circumference. Now, if they want to know how much it's going to be with 15 revolutions, all you have to do is multiply 15 by the 26 pi. So 15 times 26, that's 390 pi. So multiply that by pi, and I get about 1,225.2. Now it says to the nearest foot. So remember, all of this is in inches. So what I have to do is I have to divide this by 12 to get my answer in terms of feet. So when I divide this by 12, I get about 102 feet. That is how much distance this tire will make if it makes 15 revolutions. Okay, last problem. So here you have a track. Now, as you know, tracks are made up of a rectangle and two semicircles. Okay, there is an inner radius and then there's an outer radius. So for this problem, they want me to find out what is the inner radius, not what the inner radius, but what would this whole distance right here, what would it be? So here's the thing. We got to break this up. The distance from here to here is 84.39. And so is the distance from here to here. Okay, so whatever that's going to be, I have 8.39 plus 84.39 plus 84.39. Now, that's going to be this distance and that distance. Let me use the highlighter to show you guys what I mean. So that's the distance and from here to here. So now what I need to do is I need to find out what is going to be the inner distance. So in other words, this distance right here and this distance right there. So this 44.2 is kind of useless. So if I were to put these two together, that is the equivalent to the full circumference of a circle. So that's going to be plus the circumference of the circle. So 84.39, if I multiply that by 2, I get 168.78 plus the circumference of the circle, which is 2 pi times the radius. I get this number by adding these two. Now the radius is 36.8. So I'm going to make that substitution. And after this, I'm just going to put everything into the calculator. 36.8 times 2 times pi. Okay, I get 168.78 plus 231.22. Now, why am I not doing the nearest tenth? Well, all of these have to the nearest hundred, so let's just stick to the nearest hundred. So now what I'm going to do is I'm going to combine these together. 168.78. Whoops, sorry, fat fingers. Wow, I get exactly 400. Interesting. Okay, so this is going to be about 400 meters. So the distance, if you run on the inside, that gives you 400 meters. If you run on the outside, it's obviously going to be more than that. Okay, so this finalizes lesson 11.1. Please make sure that you guys are working on the extra practices and the online homework that I will be assigning in just a bit. Now, I do want you guys to look at your extra practice first because there are some problems that you do not need to do. So if you quickly turn to your journal on page 318, on 318, you do not need to do problems 6 and 7, but the rest you do. So on page 318, delete or just leave blank 6 and 7. All right, have a good day, guys.